So ask questions as I'm going, because because I'll just keep going if you don't ask questions. Okay.
Can you go over what values you put in for the no treatment in the model we did in lab? Because I think I have it right for all of the ones except A91, B91, and C91, which are the no treatments.
Okay, let me go. You mean the NPV for no treatment?
Yeah, well, yeah, just like I think I saw it, you had it up earlier. You had a picture of like the model you made
Yeah.
in Excel, and I just wanted to see what you put in those cells because I think you put something in as like the revenue 7 or like the cost 7 values, just those. So that would actually calculate a real value, but I didn't see what you put there.
Okay. So I have to find that stuff.
I think, yeah, it would be the O column, the T column. Okay, so you put 16,000 in revenue, and then
Yeah, my assumption was that the forest didn't grow over the next 70 years. And it was just a old growth forest with 40 MBF per acre. 40 MBF is a sizable amount. And it was the same thing for each of the other ones that just had different volume amounts. And so I just did the calculation the same way. So it had 16,000, which was 40 times the amount that you got per acre,
mm-hmm.
or per logs, the net amount. That's not the net amount, sorry. Then I subtracted off the cost. Then I subtracted off and that gives me the net revenue. And then I discounted these. And so this is for the do nothing prescription. That is the net present value for it, which was 854. And then I subtracted off the yearly cost. So the total number for NPV for the do nothing is 779 for
So why is
standard.
that in year 70 when everything else was in year 60? Like the last year for everything else was 65. Why did we add out to year 70?
Oh, it's just because it's the ending, the terminal value. So the plan goes out for 70 years, and we have, and so I'm just saying, okay, at the end of the 70 years, we'll just have a liquidation sale, and that's what that's why it's at age 70. So it's discounted back from 70. So we don't do anything to that stand. We just know it's there, and it has value, but it's not. We're not taking any value from it.
Oh, okay. So, okay, I'm just gonna have to go back in and add a bunch of columns. I mean, columns then
Right.
rows.
It's the exact same calculation, except there's no logging, or there's nothing going on other than being there.
Okay,
Okay.
makes
So
sense.
let's get going. I'm going to try to minimize my screen. So you have to speak up so that I know you have a question, because I can't see anything anymore other than the matrix. Get this out of the way too. So I want to develop a production possibilities curve between net present value and owl habitat. Yep. That was my NPV calculation that I was looking at. So this is the total model, and I'll go over this quickly again. These are the stands where you only clear cut harvest every 30 years, except for the initial harvest can start because it's a old growth, it's an old stand already. So you can start harvesting in period 1, period 2, period 3, or period 4. And then you say if you harvest in period 1, you replant and you harvest it again in period 4, plant, harvest again in period 7. So that's just the progression of a set of prescriptions, which we call a management regime, because it's not a.
I do have a question,
Yes.
quickly. Is there any way we could move the due date to next Wednesday or Monday even? So I'm not sure that I'm going to be able to get the entire thing done by this Sunday, just because of the conference.
I have no problem with that
Okay,
because I'm not going to be able to look at it either.
okay, sounds good.
I'm going to be play catch up. I just saw Ed. Ed, are you there? I tried to admit him. Let me stop sharing. I don't see him. Okay, well, I'll just go back to it. Maybe he'll come back. Okay. So okay, so these are the stand class A, where you'd have a thinning in it, but the first rotation is you're just purely harvesting the existing stand, and then you have a thinning, and then you have another harvest, and then you have another thinning for A21. And so each of these are kind of the same thing, except they just start at different times. And then we have A31, where we burn. So burning enhances wildlife habitat. So when we just do net present value without caring about wildlife habitat, you never burn. So burning is an integral part of most southeastern forest management plans. There is no wildlife habitat showing there, but down further, if I can find it. Okay, so this is the habitat for periods 1 through 7, and for the burn habitats, you have higher values for each period. If you look at this one versus this one, you can see that they're similar, but this one is always more potential wildlife habitat. Let me go back up to the top. And then you have the B stands, where you do the same thing, but it's slower growth. It's a lower site index. Then you have the C's, the same thing. It's just a young stand, but you still do the same thing. Then you have all these H's. All the H's are just habitat, are just harvest levels for each period. So for period 1, I get 18,571. And if you look at this all the way across the top, so this is the same one we were looking at in class last Thursday. And it's even flow of habitat, because I basically had an even flow model set up in here. And I'm quickly going to go down just to show this to you again. Okay, this is the relationship between habitats. So what I did is I have it, so period 1 and period minus period 2 has to be less than or equal to 0. And all that allows it to do is you have to harvest as much as you harvested the period before every period, which is a non-declining even flow answer. And I wanted to change that to 0.8. So instead of being even flow, it'll be able to fluctuate some. Being able to fluctuate is good for net present value, because it gives just more opportunities for the model to find better solutions. So I'm changing this to 0.8, which was in the original habitat or policies in the handout. Okay, so now I just changed all those, so I can go down by 80%, or I can go up by, I'm sorry, you can go down by 20%, and you can go up by 20% between periods. So it gives a little bit of leeway between periods. And if you didn't have that, it would just like clear cut everything in the first period, and then when it grows back, clear cut everything again, which is generally an impractical thing to do. So I'm going to solve this model. Let me look at the other variables first. So this is the habitat variables. And I set it up to have a max min habitat, but we're not trying to do that, so it comes out as 0. That was in the last run. Here's owl habitat. You had to have something like 100 acres, and it's at 871. I'm not quite sure. Oh, it probably had to do that because of the even flow. And this is the park, so you have a certain number of park areas. You have a certain ending inventory. This is net present value, but let me run it again to get the one with the fluctuation. So remember, it was 10 million. So by just changing the fluctuation, let me run the model. Hopefully I can do this on Zoom. Where is the model? Go to solver, and I'm solving it. Can you see that on the screen? Solver could not find a feasible solution. Oh, okay. Come on, you stupid thing. I'm trying to get out of this little stop share box. Say, okay. So probably when I changed it, I should have changed the direction of the habitat. So where I have to, oh, here it is up here. So I labeled them as low. So this is the lower bound, and this is the upper bound. So if I go over on the matrix, oops, this will be the someplace. Okay, this is the relationship between period 1 and period 2. So I'll go back to the and remember the actual equation is, this is the equation in here with the sum product. We're just multiplying that row times the object towards the unknown row. And so it's just like a bunch of linear equations. It's exactly like it. So let's see, I'm saying it's less than or equal to 0. So I wanted the relationship between periods was it could decrease by only 80%. So yeah, so this has to be a greater than or equal to. So I'm going to change that. And oops. And remember, these things I'm just typing in, these are only labels. So they don't do anything other than remind me of what they are. So now it's just saying that is that the harvest level in period 1 has to be, or period 2 has to be greater than 0. So let me run it again. Solver, and I'm solving it. Hopefully it could not find a feasible solution. Let's get the feasibility report. So you always have these different reports, and I'm going to look at the feasibility report. Which will be right here. So this is the relationship between the prescription 2 and 3 had to be greater than 400, but we don't do anything with it. So that's the clue. So first of all, I want to find that variable. Oh, here it is right here. So that's, I want to go down on it. Oops, I went right by it. Okay, so this is -1. What's this one right here? Did you have a question, Gabe?
No.
Okay. Okay. So that didn't alleviate anything. So now I'm going to go over to the right-hand side and find this. Here it is right here. There's not supposed to be a 1 there. This is let's see, that's prescription 3, or that's a C-class land, and it didn't have a thinning associated with it. It shouldn't have had. So I got rid of that, I hope. Yep, so it's 0 now. Let's see if that makes a difference. Solver. Oh. Let me see what happens. I don't think it'll work. Excuse me. I could tell it wasn't going to work because I didn't change the relationship in that row. So let me find it. Where is it? Okay, here it is. So from row 51 down to 56, it should be it should be greater than or equal to. So I'm going back to the solver. So 51 to 56, so it's less than or equal to. I didn't change this when I went, when I was pointing out the problem. So I have to change this and just change the direction of that relationship. And I hope this works now. Okay, thank goodness. I would have had to start pulling my hair out. So after doing that, my new objective function value is 12 million. So I make some money by doing that. So if I look at it, I'm going to keep a record. I'm writing it down. NPV is, read it out to me if you can see it. 1238.
12387029.82.
Okay. And then I'll go look at owl habitat because I'm going to develop the production possibilities curve between net present value and owl habitat. And you do about the same thing, except you're doing it with just wildlife habitat in general. Here it is. So it's 393. 393. Okay. And so I write down 393 for owl habitat. So I have one solution, but I don't have a production possibilities curve. I have to run it several times. And while I'm thinking about it, excuse me. So owl habitat wasn't limiting at that time for that solution, but I'm going to put it to 0. Is I'm not requiring any owl habitat. So that essentially allows me to get down to the worst habitat to the best habitat. Excuse me. Okay. So if I ran it again, it'd be the exact same thing. But what I want to do is I want to get some I want to get the opposite solution. So instead of maximizing net present value, I'm going to maximize owl habitat if I can find. So this is net present value. There's a 1 there. I'm going to change that to 0. So now I'm no longer maximizing net present value. And I'll put a 1 here, and I'm maximizing owl habitat to see what happens. So it's going to change the results, basically, of course. If you change part of the model, you change some of the results. So solver. So now you understand what I'm doing. I just changed the objective. What am I trying to do? What I'm trying to do. So I solve it again, comes up with a solution. I say, okay, but I want to get the sensitivity report. Let me click on the answer report too, just to look over for you. I think I quickly went over it in class the other day, but so down here in the bottom, I have the feasibility report. I don't need anymore. It's not letting me change it. Okay, there it goes. It just changed it. It just takes a while to change it. So I'm deleting that file. This is the answer report, and I just maximized owl habitat, And remember the original value was, it's just telling me what it started at. But now since we're maximizing it, the owl habitat is 11,056 acres. And the you see where I'm getting at, I'm assuming. Now we have net present value. It's not showing up on this, it doesn't have the label that I'm looking for, but I can go back to the actual matrix and find NPV in here. The share screen is really a nuisance. Okay, so now it's down to 7,394.952, not point, comma. So you get a drastically different amount. So I want to find out some of the solutions between maximizing owl habitat and maximizing net present value. I want to develop a curve that goes between those two. Now, to do that, you go to the sensitivity report. That's a sensitivity report. Popped up pretty quickly for my screen. And I'll go down and find owl habitat somewhere on here. Here it is. This is owl acres right here on 46. So this was my objective function. So if I look at it, I said, well, I want to get some more net present value out of this thing. So net present value is right here. And it says, am I on the right? Yes. If I increase, let me go back up and tell you about these columns. So this is the current objective function coefficient. And this is how much you can increase it or decrease it, and it'll change the solution. So I want to get more, I want to get more money. That's what I'm saying. I want to get more NPV. So let's just say, it says I can increase it 0. I mean, I can increase it by any amount, and I'm going to get more dollars. So let me have an objective function value of 0.01 for NPV. So go back to the matrix, change this to 0.01. That'll probably get me probably wipe out owl habitat, which is that little number, because owl habitat is in acres, whereas NPV is in dollars. And so there's always going to be many more dollars than acres. Okay, so now I solve it again. So what I'm doing is actually using those accounting variable coefficients as weights to get more or less habitat in this case. So I'm solving it again with the new objective function values. Solver. Okay. Solve. Okay, I'll just say keep it. So right now it's at 1.2 million. So I get a hell of a lot more money that's coming in there for that. So let me go back and see how much habitat I have and how much NPV I have. So just that little coefficient, 0.01, it pretty much wipes out my my owl habitat that I got. So just that small weight. So I'll write down, it's going to be the same as the first one. That is the same number as the first one, right? No, it's not quite. So it's 12, 3, 8, 7, 0, 4, 0. So you gained, or you gained how many dollars? $11 you gained by doing that into habitat, or that you didn't lose. You still have 393 as your minimum habitat. 393. So now I'm going to look at the, we'll have to solve it again. I want to go back to the sensitivity report and solve it. Solve. Okay. Oh shit, that was stupid. I have to solve it again simply because I didn't save the sensitivity report. Because this screen sharing thing is blocking my view. So go back to the sensitivity report. I want to save that also. That's all I'm saying. So this would be sensitivity report 2 coming up shortly. I'll have a little bit of coffee on the way. Any questions? Okay, sensitivity report 2 right here on the bottom. Click on that. And now I can look at NPV indoor owl. Okay, this one was the NPV and this one was the owl. So both of them are, it's owls only weighted 100 times more, and it's not going to really affect NPV. So I can use these numbers here. Let me go to the owl habitat. I can increase it by 12.81 and it'll still stay the same. So I'm going to increase it to 12.9 and see how much habitat I'm going to get. So now the coefficient for owl habitat is going to be 12.9. So I increased it more than that allowable enough. So I know I'm going to get more owls. So I'll go back to the Angola Bay matrix. There's actually ways you can do a batch job, but we're not going over that. So I'm going to change this to 12.9, right? 12.9. So I'm weighting owls much more. So I should get more owl habitat. I always click on the objective function value before I start, just because it's a habit that actually saves me time. So I'm going to solve it again. And I'm going to save the sensitivity report again because I'll need that.
Are you going to post this recording for the Moodle so we can review it?
Yeah.
Okay. Because my computer is running very low and I cannot find an outlet anywhere. So if I disappear, that is why.
Okay. Thanks for the warning. So by increasing, by increasing it 12.9, I'm still at 9.3, but everything stayed the same. Okay. I'm going to increase it by 13. Maybe I didn't increase it enough. So I just went back and now I'm going to solve it again with the new weight on owl. And I want to save the sensitivity report. Okay. Takes a while to, for some reason, to save it. Okay. Well, let me go to the sensitivity report again. So this is allowable decrease, allowable increase. So I want the allowable increase in my owl habitat. So it's at 13 now. I should be able to increase it by 0.8 or 0.9. So make it 13.9. And I'll get a new solution. That's what it should be doing. So I'm going to change it to 13.9. I want to start deleting some of these sensitivity reports because we'll have a bunch of them. Okay, so it's at 13.9, right? So I'm changing it to 13.9. Let me just change it to 14. What the heck? So I'm giving more weight to owls. They should be getting more owl habitat. Or owl acres. I'm solving it again with the new weights for owls. Solve it again. I'm going to save the sensitivity report. Okay. Hopefully I get something out of here. What's probably happening is I'm not increasing it enough. And so the all I'm getting is decimal points, and it's not showing up on the screen. So I'm going to make bigger choices. Okay, so this time at 13.9 or at 14, it was the weight. So I have 414 acres of owl and still 12,358 $496 dollars. So I haven't lost too many dollars, but I've gained what 20 21 acres, not much. I'm going to go through this quicker now, simply because it's taking me a long time to get anywhere and I'm running out of time quickly. So instead of going to the sensitivity analysis and getting how much you can increase it by, I'm going to just say, I'm just going to increase it by larger amounts so it can jump up faster and make that production possibilities curve. By doing what I'm doing, the production possibilities curve won't be as smooth, and it might have some long intervals where nothing happens. So anyway, I'm going to double this, 28. And actually, I'm not even sure if 28 is going to be enough, but that's what I'm going with. Solver, where are you? Sensitivity, save it. Okay. I think I got a bigger boost this time. Let me go across here. So I have 609 now for owls, 609. That's a big jump. And 11,859, 923. Let me double it again. So let's go to 56. I don't think I saved the reduction possibilities curve, or this, or the. I didn't save the sensitivity analysis, basically because that's taking too much time to do. But it comes up to 689 owls now with a weight of what was the weight? 56, 56. And I'm down to $10 million. So it's starting to cost me money having more owls. 9-1. Oh, I'm reading the wrong one. My bad. I was reading harvest. 11,577,243 dollars. So let me just go right up to 100. Now, hopefully you understand what I'm doing with these number changes on the objective function row. So I'm just putting more weight on getting more owls. That's all I'm doing. I could be doing the same thing with getting more NP or less NPV, but I keep solving it with the different objective function values. So if you have any questions about the procedure I'm going through, ask now, but it's just basically changing the weights on owl habitat in this case. And you'll be changing the weights on habitat. I'm not going to save the sensitivity report again, simply because it's taken too much time. Go over, and this time at 100 weight, I get 11,032, and 8,430,518. Okay, I'll do it one more time, and then I'm going to say, okay, that's enough points to develop my production possibilities curve. Now, if I was doing this in reality, I would want to have every point in between, but that would be taking too much time, and you don't need to put every point in between also, simply because sometimes it's moving very slowly, and I was just increasing the weight on owl habitat in jumps. So let me go up to owl habitat as 150. Yeah, let me do 150. Where are you? And okay. And the objective function, by the way, is meaningless because it's both dollars and acres of owl habitat. So this number here is just the summation of owls and money. So I'm at the same thing, exact same thing. I didn't get any more owl habitat, and I didn't lose any more money. So 150 wasn't significant enough of a jump. I'll put 200. 200 should do it. Okay. 132. Gee, I didn't get anything. Let me go to 300.
All right, the computer is going down. I will watch the rest of the video tonight.
Okay, Mimi.
See ya.
I'll see you later. Stop by my booth. Okay. Okay, hopefully we got something. Nope. So at this point, I probably should go to my sensitivity analysis again, so I can know how much I have to increase it by. So I'm going to solve it again, it's the exact same weights. So I'm solving it, and I'm going to change the sensitivity analysis so I know how much I have to increase it by to make a difference. This will be report number 4. No, it'll be number 5. I'm not sure which report it is. Maybe it's number 3. Let's see. It'd be 300 in the. Okay. Okay, so here it's telling me I can increase it by 68 and I should be getting something. So let me increase it by 70 just to make sure. So I'm going to back to the problem, change the weight by, what did I say, 70? So 370. So I should get a new solution with 370. Solve it, solve it, solve. I'm going to save the sensitivity analysis just in case I need it. Okay, sensitivity analysis 5 is what I'm on. Let's go over here. And I have 1142 and 8 million 0 4 5 6 8 1. So eventually I can do this. I can keep increasing the weights, but the maximum, I already know what the maximum owl habitat is. It's it would be 11,056, and so now I'm at 11,042. So that's a small number of acres difference. Do you see why do you remember why it's the maximum was 11,056? That was the first number that I achieved when I had 0.
Oh yeah, when there was
NPV.
no weight to NPV.
Right. So I'm going
Oh
to
wait on
I'm
owls.
going to take the numbers that I have and I'm going to make the production possibilities curve and then have a discussion on it. Okay, so and again, I typically would try to get every point, but for the classroom purposes, and I don't have enough time left, I'm going to just jump into making a new, well, I guess I can add it on right onto this, right? I'll just have a new sheet. Okay, so my sheet here, I have NPV and owls. And owls are in acres and NPV is in dollars. So go down, I'm just going to read the list. So the first one was, I wish I copied these numbers. 12,387,029. And owl habitat was well, let me put these in order. But the owl habitat was 393. I'm just saying putting them in order so I can graph them more realistically. So let me just put a insert another row. And so this, the maximum owl I had was 1, 5, 6, 11, 5, 6, 11, 5, 6, and then the minimum net present value is 7, 3, 9, 4, 9, 5, 2. Okay, and then the next one I had, so I'm doing from maximum owl down. So I had several different ones in between here. So let's see. So I have 142, 689, 609, 413. Okay, so I'm going to just try to put these in order as I'm going. I think I had three points following this. So the next one down is 1142, which gave me 8,045,681. And the next one is 1132, which gave me 8,430,518. And the next one is there's 32, so 60, 689, and that one gave me 11,577,243. And I guess I had some more in here. Insert. So that one, so I have two more I have to insert. Okay, so I had the next one, 609. 609. And 609 gave me 11,085,9923. And then the next one was 14 or 414, which gave me 12,012,358,496. Let me see. Okay, I think those are the only points I did. So I'm going to graph these points. And see what it looks like anyway. So I'm going to insert a scattergram with lines connecting it. Okay. So there's probably another point where it goes down to 0 if I don't do anything. So let's put in a point for owl habitat, or for net present value of No, that's okay. I'm just gonna change the axes on here so that it looks a little bit more dramatic. So I'm gonna start the first axis, format axis. I want to start it at so that must be, that started at 7 million. The minimum, I'm sorry. That would be 7, 1, 2, 3, 4, 5, 6. Okay. And do the x-axis, that's for owl habitat. That started at like 400. Okay. So this is a production possibilities curve. And what it's saying, let me put in the labels on the axes just so they might say something else. Production possibility curve. This is what it would be called in economics, at least. And I want to format the anyway. I can't see the things to put my axis on. Maybe I can just label them straight out. Format axis. This would be the nope. Fixed options. How about that? Yep. Okay, I'm going to stop trying to figure out the axes, what they are or what they call them. But the vertical axis, that's owl habitat. This is in acres, and this is the x axis. That's an NPV, and the units are dollars. And as you can see, there's a trade-off between these two things. So and a lot of the objectives that you have in forestry and forest management, you're trading off one thing for another, or acres of owl in this case to dollars of NPV. Now this straight line between here and there, I'm sure it's because of the way I was jumping ahead in the analysis of it. So this probably goes out a lot slower, and then it'll have a faster drop out here someplace. So right now, that straight line is purely because I didn't fill in all those points in between. So you should fill in the points in between just to make it look better.
To what degree? Like how many times do you want us to run it?
I would like you to get at least 10 points in between those two, between this point here and this point here. So I only have 1, 2, 3, 4, 5, 6, 7 points. And 2 of them are so close together, which would be the 689 and 609, that just doesn't show up. Which would have been right down in here. So if you could just move up to where, up to the other point by using the sensitivity analysis and just trying to fill in those points. But the value of a production possibilities curve is for decision-making purposes. So if you're a manager, this is two pretty clear choices the way I graphed it, but that's just because I didn't fill in all the points in between. But it would be, okay, if I'm managing here at 689 at about $11 million, and if I just add a little bit more weight to it, I would just jump over to this one, which is I've dropped down to $8 million. And so you're losing a lot of money from going from this point to this point. So if you knew the curve, you would choose a point along here where your opportunity cost is equal between having more owls or having more net present value. So it's a great decision tool. And if it actually looked like this, you have a pretty clear decision. Okay, if it's going to jump from here to here, which it's not going to, because we know there's other points in between here and here. So this one's between 700 and 1100. So between these two. So let me do a split the difference between these two and see if I can get a point in here. So let's see, go back to the model. So 370 is the last one I did. So it's between 56, I'm looking at the weights, and 100 is where the big jump happens. So if I did if I did 56 to 100, which is where the big jump starts. So what's the middle of that? That would be 70, 72. So I'm changing this to 72. This will be a new solution. Oops, I'm looking for my solver. Okay. Solve. Okay. And now we get 949, and net present value is 326. Okay, so now I have a new point. So the new point would be between these two. So let me add another row above here. Insert sheet row. Is that correct? Okay, that's correct. So I was at 949, and 9898. 326. So I want to select data again. And that's the series. I want to add. Nope. Okay, cancel. Well, it looks about the same.
Yeah, I think it automatically added your point when you put it in already.
Oh, okay. So that's interesting right there, is that it's a linear trade-off between dollars and owl habitat. Let me just make this larger. And so you have a direct trade-off between dollars, and there's probably a little bit of a curve in there, but that midpoint doesn't give it much of a curve. So what it means is that as a manager, if you're going for owls, someplace probably along this straight line is your desirable solution. Now, actually achieving that is a difficult thing, but you have the solutions to each point about how many acres you should be doing for harvesting and burning. It all fits into that. So this is a production possibilities curve. This is what I want you to make for the current lab 7.
Okay.
And I think I went through everything I wanted to go through. And do you think you can do this, Gabe?
Everything makes sense once the solver's set up, but I got a little bit lost whenever you added all the variables to the model we had before.
Well, that makes sense. Let me go to the model.
Other than like once the model is set up, that like obviously that all makes sense intuitively, but like where you added, so I have everything here. Let me split screen mine so I can actually see what I'm looking at too.
Okay. I'm going to
So
stop share and you can share.
well, no,